Welcome to today's webinar. The topic today is design of masonry structures in Rfem 6 using finite element analysis. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the content of the website, the German and English webinars, newsletters, customer projects, and so on. I will be the moderator today, and I will answer your questions together with Frank. And Uli will do the presentation, but my two colleagues can introduce themselves.
Hello, my name is Frank Vollstich. I'm responsible for product development and quality management. And today I will answer your question.
Hello, my name is Uli Lex. I'm responsible for quality management, for development of masonry and development for glass structures in Rfem. And today I will be the presenter of the webinar.
Okay, thank you for your introduction. Then we can switch off our webcams that the attendees can see the full screen. Some words for the attendees who participate the first time. You can see the control panel on the right side of your screen, and you can show that with that arrow, and then you can enter a question here, and we will answer you. If you don't get an answer because there are too many, you will get an email after the webinar. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, then I hand over the screen to Uli. Uli, it's your turn.
Yes. So today's webinar, the content of today's webinar is masonry. Today I want to model a building from beginning in Rfem. In the second part, I want to take a look on some detail points, especially connected to the masonry material. And in the last part, I want to show how you can document the results of the program. In the first part, we will insert a small building in Rfem, and I want to show you how to do it. In the second part, I have chosen some separate models where I have prepared it and to take a look on some details. And as I said, the last part is the printout report. So now I want to switch to the program. Okay, I have already created a new file, a new project in Rfem. It is important when you create a new project that when you want to use masonry, that you check on the add-on masonry. Otherwise, you cannot use the material model for masonry design. So as a first part, I want to create a new material. You can use here some values from the database as material type masonry. Maybe you can choose one product you want, maybe Porotherm 38, and have to choose the material model, the orthotrop masonry plastic. If there are some products not available in the database, you can also insert it manually. In this tab, standard classification, you can choose the grouping of your product. You can choose the mortar you used. You have to insert the dimensions of the stone, and you have to insert the compressive strength. With all these values, automatically Rfem computes the data what are needed for the material model. It is a module of elasticity, the shear models, or the allowable or the ultimate compressive strength, or the ultimate tensile strength. So I want to create now a second material, maybe for the inner wall. It's the same as before. Choose one product, maybe this Protem 7050, and go with OK. The second thing I want to do is to create a thickness. All surfaces do need a thickness. So the first thickness is already in that it's 250 millimeter with concrete for the foundation maybe. The second thickness I will create is 200 millimeter for the concrete slab. The third thickness I want to use our masonry material, 380 millimeters. And the fourth thickness, I want to use the material for the inner walls with thickness 170 millimeters. If I have done this, then I can to start with the modeling. Here I have a building with the dimensions 7 to 9 meters. I use my grid points to create the first floor, 7 to 9 meters. Can here assign directly with this select boundary my foundation plate, thickness 250 millimeters concrete. Okay, and choose the lines. So in the second part, I want to change my work plane and create a new surface. Want to choose now the thickness for the outer wall. Okay, with a height from 3 meters. I can change my work plane and create the second walls. Now I can directly copy these walls and the first things are done. Now I want to create the first concrete slab. Okay, and choose the outer lines. So the second floor will be in the front a height of 4 meters. And in the back, a height with 3 meters. And as I did it before, I can use select boundary with 380 millimeters and can select and copy the surface. And at the end, the wall in the front and at the back. Choose all these lines, turn around it, and choose the rest of the lines. Okay, now I want to create my inner walls. There I select only the ground floor. Change my working plane. And start to create the lines for the inner walls. 1, 2, 3, and 4 meters. My grid have a space from 1 meter, so I can use it here directly for my modeling. Change my working plane. And just copy the lines to these points. So the second wall is in the second floor. So I cancel my visibility mode. And create here new lines. And the second wall is maybe from here. One, 2, 3. To here. Here you can see when I cross the line, then one point is catched automatically. This can be set in the detailed setting for catching the lines. So now I have created all lines for the inner walls. Then I want to choose select boundary for creating a surface. Choose my thickness from the inner walls. The material is automatically changed. Okay. And choose here my walls. Here. And the third one. So now all my walls are created. As the next part, I want to create some openings like a window or a door. I select again my wall in the front, change my work plane in this plane I want to work. I change my space of the grid points, divide the space 2 times, and now I can use the option create a new opening with 250 high and 150 width. I create a new window. Here it's one. I just want to change it to 250 meters. And create a window with 1 meter to 150. The same maybe in this part. And the same in the second floor. Maybe a little bit bigger window. And the same here. In the inner wall, I want to have an door too. So I select my inner walls. I can switch off the background, the hidden objects. For better modeling, I can change my working plane, select the grid point, and can create now here a big door. So in case of using material masonry, then it is important in case of openings that you have or that you create something like a lintel above. It's because if you do not assign a lintel, it could be that the system will be unstable because of the missing tensile strength, or the missing ultimate, or the very small ultimate tensile strength in the area of the above the opening. So that's why we create here now a lintel. I double click on the line, create a new member. It's a member type beam. I want to select a new section. I can create a new section. Maybe with the width of 380 millimeters and the high of 150 millimeters. Material concrete is okay. Okay. And the second thing is when the window is too big, then it is good to have this lintel a little bit inside the wall. It's because that the force from the lintel not directly insert to the material masonry in one FE node. So that we create a copy of this node, create a copy in X direction, maybe 125 millimeters, and the same on the right side. And create here a line and a section too. Okay, and okay. The same for the other openings. I select all these lines, double click, and assign a new member. Okay, the same I will do in the inner wall. I assign a new member. Here I use a little bit bigger section, so I create a new one, maybe 170 millimeter width and 250 millimeters high. Okay. Okay. Here I could create I could let be this lintel in the masonry wall too. It would be maybe good on this place. But this example I will have in the details. So the next part on such a building is on the top of the masonry. We need something like a ring beam. You can create it easily in Rfem when you select all lines where you want to assign such ring beam, and can assign again one member, choose a section, create a new one, maybe 380 and 250. Okay, and apply with OK. And then you have created this ring beam. So as a last part for modeling, you have to take a look on the wall slab connection. It's a very special thing for masonry buildings. Each time on a place where the masonry wall does not stand fully on maybe a concrete slab, you need a special connection. It's called in Rfem slab wall connection, and you can assign it if you double click on the surface and assign a new hinge. Create here a new line hinge, and here you will find the option slab wall connection. As I said, it's to use each time where the masonry wall does not stand fully on the concrete slab. In case that the wall stands fully on the slab, then the material model itself can handle it. Only in case that the wall is not completely supported, then you need this hinge. So if you have checked on the option, you get the new tab with wall slab connection. Here you can insert the offset, maybe 150 millimeters. If you have a block width, then you can insert it. If not, then we let 0. We have to choose the lines where this hinge should be assigned. It's all the lines, all outer lines. Oh, just I had to go back one step. I had at first to connect these lines and members, because here I have a double line, so I just use this option connect lines and nodes. So I will have no double lines and nodes in the system. Then I can assign this hinge again, create a new line hinge with wall slab wall connection with my offset 150 millimeters, and assign it all these outer lines. Continue with OK. And now it's important to generate this line hinge with this button on the left. Now 2 line hinges are created. I can continue with OK, and I will see that my line hinge for the masonry wall is created. Here I can double click. It's yellow because it's created from the master line hinge, and here is a force moment diagram assigned. Okay, the same I will do for the slab in the first floor. Double click on the surface, assign a hinge, create a new line hinge using slab wall connection. If I have the same offset, I could use the same hinge too, but now I generate a second one. Choose all outer lines. Continue with OK. Generate the lines. Continue with OK. And now I can see that for the wall above and the wall downside created as two separately hinges. Okay, as a next step, I had to choose and support. Here I want to choose and support of the base plate, support easily as a rigid plate. Okay, and on the last step, I had to create some loads. The self-weight is created automatically. As a next step, I will create the live load, post load. Okay. Choose maybe for the self-weight 1.5 kilonewton and assign it to my assign it to my slabs. Okay. And the same for the imposed load. Maybe 1.8. And continue with OK. The combinatoric is done automatically if you have set the combination wizard on. Then you can choose the design situations. You can create a combination wizard where you can choose a static analyze setting. For masonry, it's good to compute geometrically linear or large deformations. It's the best for the material model. And for the nonlinear plastic material, it's important to increase the number of load increments, maybe to 3. You can allow a little bit more iterations, and here you can save the results of all increments. Then you can take a look on the increment 1 or 2 too. Okay, continue with OK, and you get now the load combinations here. So as a last step, we can take a look on the mesh settings. For masonry, we use normally something about 0.25, 0.2. You can OK and apply. Then the mesh will be created. Please be a little bit careful that you have a good mesh, because it's very important for the calculation, for the nonlinear calculation. So after that, we can compute the first load case, and when it's computed well, then we can go to the second part, to the details. Here you can now see the calculation process where we have where the system is computed with the first load increment, now the second, now the third, and then it should be finished. Exactly. Okay, now I want to switch to my detailed systems, and here I have the first one is a part of masonry where you have maybe some outer wall, exterior wall, and one interior wall. Mostly you have two different materials, maybe as I choose it before, like a wall with 380 millimeters width, and for the inner wall, a different material with 170 millimeters. If you build up these walls, then generally the outer wall is created, and after that the inner wall will be created. So the connection between these walls is not rigid, I would say. Here are a lot of things, things you can use. One thing is you can use such a wall connector. I looked in the internet and found something like this. This is a wall connector. It is assigned in each row of the masonry stone and connects these both walls. So, but this wall connector cannot transfer some shear loads, I would say. These connectors can only transfer tensile loads. So, and how do you can create or consider this in Rfem? I want to show you now. When I take a look in the data sheet, I will find that one connector can be or have a maximum tensile force of 0.5 kilonewton. So it's assigned in each row. Then you have 0.5 divided to 0.25 from the height of my stone. Then I will have a force of 2 kilonewtons per meter in this edge. To create this, I can use the special object line release and create here a new one. As a release type, I can choose a partial activity in Y direction. And this partial activity could be that the connection is released from a force of 2 kilonewton per meters. In the pressure direction, I would say it's fixed now, but here you can release it too. So this release I can assign to the surface. Okay. I can say, okay, my released objects after that are the surfaces. Can continue with okay. Now the whole line is released. That's why I have to assign on node on node 14. This is this node. A new support. It will get my system will get unstable. Okay. So after that, I will create a new force, maybe an horizontal force of 5 kilonewton in direction Y. Okay. And want to compute this system. So if image, I set it as before, like about 250 millimeters. Here I increase the load increments that I can show you the results better. So you can see that the inner wall is released from the outer wall. When I go some load steps back, maybe in the first one, we can see that the lines are connected. We only have a force of 1.4 kilonewton. And when I increase the load, then you can see that the release of this inner wall is getting on. As a test, we can create a second load case where I copy the load 1 and change the direction of the load. And here it should be now connected to the outer force, to the outer wall. And this is exactly that what we want to have. Okay. As a next example, I want to show you my system with the lintel. Here I have the problem that the connection between the inner wall and the outer wall is not, I would say, not connected to. Only the lintel or the force from the lintel should be reacting in this outer wall. So I can continue as before and create here a new line release. I assign it to this line. Okay. Now I choose the release type fully because I'm not sure if here if on this place is really a wall connector build. So on the safe side, I did not connect these two walls on this place. So I have to release the wall. And now I want that the force from the lintel acting is not released. It should be acting on this outer wall. That's why I can define this definition object, my node 4. So there is no release created, and the force is acting on the outer wall. Okay, continue with OK. And now I see on this one node is no new node created, and here is a new node, a release node created. Okay. just take a look on the results. And when I take a look on the deformations, I see that my masonry material is released, and my lintel, my force is acting on the outer wall. I can also see this when I take a look only on the outer wall. And here I see that the whole load from the lintel is acting on this FE node, on this one FE node. Maybe this could be also a problem, that here so much load is acting on one node. If this is a problem, then you have the possibility to copy this one node. And a second time in the other direction, and create here or assign here a small beam, maybe a rigid beam. And rigid beam that the force is smoothed in this point. In this point. If you take a look on the results, it should be the same as before. Only the smooth in this one node the force in this node is a little bit smoothed. So this could be avoid some problems if one point of the material is overloaded. So here you can see when you take a look on these criteria, and maybe not the criteria. If you take a look on surfaces and the stresses on this alpha, you can see the load distribution in the wall, and you can see that we have like it's common for masonry, a distribution from maybe 60 degrees in the wall, and the same you can see in the support reaction where we have in this area this load from the lintel. Okay, on the second side, there could be problems. There could be problems too. When we have here now a too big force from the lintel, it's depending what is on the floors above. It could be that on this place maybe should be located a concrete column, but this is also easy to do. When you double click on the line, can you create again a new member? As on beam, and create here a new section. Maybe 170 to 170. as a concrete column. So one thing you have to do, or you have to think about, is that the masonry wall is now connected fully with the concrete beam. Here you can insert again something like a new line hinge. And maybe let it free in X direction, so that no shear force is between the concrete column and the masonry wall. Okay. Okay, so these was the problems of this example, and now I can take a look on the next example. When you have something like a wall above a concrete slab, where you have no support in the floor below, then when you take a look on the results, you will see that the masonry wall is acting similar as a beam. You will have some forces like a pressure arc in the masonry wall. It's normally we have only to know it, because when here now should be created afterwards an opening, then this pressure arc is destroyed and the behavior of the wall is different, and therefore you need maybe more reinforcement in the concrete slab. I want to show it now. When we take a look on the deformations here, we have 7.9 millimeters. When I create now an opening, maybe for the heating or something else from the house technique, then you will see that the deformation of the wall is increasing a little bit. Therefore, you need more reinforcement in the concrete slab, and therefore you have to consider it in your static model. So you see the deformation is a little bit higher. When we take a look on this trajectories, you see this pressure arc is destroyed. More forces is acting on the concrete slab. Therefore, you have to consider it. So the last example is one example from the roof, from the top floor. Sometimes you have to consider some wind loads, tension loads from the ring beam, and have to anchor this in the concrete slab. This you can do easily when you create a new beam. You can here use the tension beam, and you can insert this tension beam into the surfaces, maybe like this, and tension, and like here. Here I want to change the section. I can create a new section. I have created already maybe an section 12 millimeters. Okay, as a tension. But now when you create the mesh, please be careful, because you are using now a tension beam, and the tension beam is not meshed, it's only meshed on the end points. And here it's generated or integrated to the surface. Therefore, we have to double click on the surface, go to the tab integrated, take off the automatic detection, and to take off these two lines. Therefore, only line number 5 is integrated. Continue with OK. And this means that this beam now have no connection to the surface. Now when you create some new mesh, then everything is okay again. I have created a load like tension in this direction. When I now compute it, you will see that the force is acting in the beams. Or not. Where is my mistake? Just one moment. Somewhere I have to do a mistake, but I want to switch to my second file. So here you now see that the load is acting on the tension beams and not to the wall. That it is not acting on the wall, you had additionally to assign a line hinge that the ring beam is not connected to the masonry wall. Here I created a new hinge with the non-linearity that it is fixed if the force is negative, and that means if the force is is tension, then it is free, and if compression, then it is fixed. Okay. And here you can see that in the wall there are no loads from the wind sanction. It's only in the concrete slab. Okay, on this part I want to switch to the third part and go back to my building we created before. For the documentation, you can use all things what we have in Rfem available. The most important thing is, I think, the stresses. You can take a look on these strains, because when the strains are too big, is it a hint that any cracks are existing in the masonry? I showed it in a webinar before, where on the slab, this sliding slab on the edges, where cracks are here. You can take a look on this criteria. This criteria is a hint where the masonry, where the masonry is in the plastic, plasticity of the masonry. It's not a hint that it's overloaded. There are two states. One is in the plastic state, and blue is in the linear elastic state. But here you can see where big loads are in the system. And of course, we have the printout report. If I open the printout report, you have a lot of tables, a lot of things implemented. All things what you have inside, and you have also documented the things from your material, I just want to switch the language. You have also documented the material properties from your masonry. It likes just set the language to English. And open it again. So now it's okay. Here you can see the ultimate properties from your material, what you have used for calculation. So a design check for the material does not exist because of the calculation. It's a plastic calculation, so we cannot give any ratio. It's only when the calculation is done, fully done, then the ultimate strength is okay. And this is the design check. The only design check what we have. Okay, on this part, I'm on the end of my presentation. I want to say thank you for listening and want to go back to give back to Andreas.
I'm sorry, I had huge problems with my microphone, but I'm back again. So, okay, then I continue. Thank you for the presentation. Just small words from my side. I hand over or take over the screen. Just a moment. Okay, just a small hint where you can find the recording in the next days when it's available, and also you can find the models just under news and events. I switch to English. News and events. And here, events, you can find the webinars. And then you need to scroll down. But you also get an email in the next days when the recording is online. And then you will find the recording here. And also you can already find the different models of today. Okay, that's also all from my side. Thank you for your attention. Thanks to Uli for the presentation. Sorry for the disturbing with the microphone. I wish you all a nice rest of the day and bye-bye.